right, looking at problem, let's do number 5. Says C equals 0.80. That means you want a confidence interval that's 80%. So you want to be able to say, you got to remember when you're doing this, and one of the questions asks you this, is this a probability? This isn't a probability. This is you're setting up an interval. You got your point of estimate in the middle, and you're saying, all right, from here to there, I'm 80% confident that the mean of the whole population is going to fall in there. All right? Not that there's an 80% probability that it falls in there, but we're confident with the 80%, or we're 80% confident that the mean will always fall in there, no matter what samples we pick or whatever. So that's what you're saying. Now with this, on number 5, they wanted you to find the ZC. That's your critical value. So you're looking for that critical value. Well, what you're looking for is, you have your normal curve there. We want 80% of the time to be in that area. What's that leave over for each of these two? 10. You subtract that from 100 and then divide by 2 because you have the 2 ends. So 10% there, 10% there. Well, what we can do, there's a couple different ways we could do this. We could use the chart, or we could use our calculator. I'm going to show you how to use the chart, then we'll talk about the calculator. On the chart, if I'm looking at the chart, we want to look at the negative side, but our answer is going to be a positive. Okay, because we're just looking for a critical value. So we're looking at the negative side just because we're going to look at this part right here. But what do we know about this critical value and this critical value? They're just opposites of each other. All right, so one's a positive, one's a negative. So we want the negative answer. We're going to look at the critical value, or the z-score, that has 10% below it. Well, if that's 10%, then that means 0.10, right? So you go on your chart here, and you use the chart backwards. You try to find the thing closest to 0.10 in these scores. So if I look on here, what's the closest? Looks like 0.0099, is that right? And all we do is we match it up. It says negative 2.33. Am I looking at it wrong? And again, we don't want the negative, we just want the positive. That's our critical value. That's our critical value. So this one's negative 2.33. This one's positive 2.33. Anybody else do number 5? That sure doesn't seem like what I got when I did it. Oh, no wonder. I looked at 0.01. What should I be looking at? 0.1. So we want 0.1, not 0.01. 0.1003, that's pretty close. So we look at it's 1.28. Is that right? That's our critical value. Make sure you're looking at the right number. So you could use a chart. Now, you don't want to use the chart, even though I think the chart sometimes is a little easier because I don't feel like getting out my calculator. Does anybody remember from last chapter? What do we punch in the calculator if we're looking for the score right here that has 10% of the data below it? What do you hit on the calculator? Does anybody remember that? It was on that test that we just took that I was mad about. Second vars. Since we're going backwards, what do we do? Inverse norm. You hit inverse norm, and since we're on the Z chart, all you have to punch in is the area. Now again, my calculator, this calculator is different. But all you're going to punch in is the area, then hit enter. So our area this time is 0.10. So we just punch in 0.10. Hit enter, and it gives me a negative 1.28155157. Again, we don't want the negative, we just want the positive because we're just looking at the critical value. If we're finding that critical value ZC, if we're finding that and you put a negative on it, I probably wouldn't mark it wrong. I'd probably just mark it out as positive, but that's what you're looking for. So to find those critical values, you can use either one of those two methods. Look at problem number 9. I'm going to do like one from each section here so that you could go back and make sure you're doing them right. Problem number 9 says use the values on the number line to find the sampling error. Sampling error. Sampling error, and we're going to write this again in the notes today. Your sampling error is just X bar, the mean of the samples, minus the mean of the population. That's your sampling error. Right? So how much are we off of the actual mean? Well, looking at number 9, what is X bar? What's the mean of the population? Guess what we do with those two? Just subtract them. Somebody tell me what that is. 3.8 minus 4.27.
Negative 0.47.
That's your sampling error. That's all you do to find sampling errors. You take X bar minus mu. X bar minus mu. So 9, 10, 11, 12, shouldn't be anything hard about those. Jumping down to 13. Somebody help me out. Margin of error. That's different than sampling error. Sampling error and margin of error, two different things. Somebody help me out by the notes we had last time and look for E and be ready to tell me that formula here in a second. Now we're getting a little tougher. Now you're actually doing some work. E equals what? ZC print or sigma over square root of n.
The other one was like they were both right beside that.
So this is the other one's just this one, or this one's the other one expanded out. So this, remember from last chapter, this is your standard. What was it? Standard error. This is your standard error, and that's all. It's just expanded out. What's the first thing we're going to find here? Do we know the critical value? We know C, but we don't know the critical value, right? We need the Z-score there. So we're going to have to find that, and times, instead of sigma, as long as our N is 30 or larger, we can just use S. So instead of sigma, because usually we won't know the population standard deviation. Remember, this is the sample standard deviation. So we'll just put 5.2 on top. Square root of N, which is 30 on bottom. Now, we still have to find that, and we're gonna find that like we did on that other one. If I look at my normal curve here, 95%, that's our confidence interval, 95%. So we want 95% of the time to fall in that area. What's that leave me for each of the two sides? Say it again. 2.5%, 2.5% on each side. We change that to a decimal, bump it over 2 places. 0.025. Again, you can either use your calculator and punch that in inverse norm, or you could use the chart. If I look up 0.025, don't nobody scream out the answer yet. 0.025 on my chart. Let's see if I can do it right this time. 0.025, that's right there. I get 1.96. Is that right? 1.96? Is that what the calculator said? Yes, no, maybe?
Pretty close.
What'd the calculator say?
Negative 1.95.
And probably if you look after the 5, it's probably got something that rounds it up, doesn't it?
9.
Yeah. So it's a negative, but we want the positive. Now we just do the math here. What's 1.96 times 5.2, then hit equals, then divided by square root of 30. Whenever you're doing this formula here, take the two top numbers, multiply them, hit equals, and then hit divided by square root of 30 on 1.86. That's our E. That's what E equals. That's the margin of error. Now, why the margin of error is important is because we're going to make a confidence interval later on this. We're going to make a confidence interval, and we're going to say this is our point of estimate, our X bar. How far up from the X bar are we going to go? 1.86. We're going to go up that far. How far down are we going to go? 1.86. And we're going to say in that interval right there, we're 95% confident that no matter what sample we pick, the mean is going to fall in that range. We're always going to be in that interval. We're 95% confident that it's going to fall in there.
Wait, how did you get 1.96 again?
That's the ZC. So I used the chart. You look over here, this area, it's 0.025. This area is 0.025. We just need the one of them so we can find this Z score right there. That's the critical value. So on my chart, I just used 0.025. Malachi used his calculator and he punched in inverse norm and then put in the area 0.025. So either one of those two. Some of them, if you look on this chart, and part of the reason that I use the chart, even though I screwed it up earlier, if you look right here, it says critical values. There's certain critical values that we use over and over and over again. Well, we were at 95%. If we look at this little chart right down here, it says 95%, and it says the critical value is 1.96. So it just tells me. It tells me for 80%, 90%, 95%, 99%. Because those are 4 critical values that we use all the time, or 4 confidence percents that we use all the time. So it tells you them right here. So instead of doing this, finding that every time, if it's one of those 4, you could just look at the chart, this little chart right here. And it'll tell you for 80, it's 1.28. For 90, it's 1.645. For 95, it's 1.96. For 99, it's 2.575. So you could just use that All right, now, Sydney's over there going, why didn't you show us that first? Well, because I still want you to know how we come up with it. Not that it's just on a chart somewhere, and that's how you know it.
What copies was this supposed to do?
1 through 28.
That's it.
Yeah, that was last time. Next one, jump down to, you just want to do all 17 through 20?
Yeah.
Every time Malachi says something like that, the amount that I do gets smaller and smaller. I don't know why it isn't always you. Oops, that's A. That's not 17, that's A. I'm going to show you several things on these, even though they only ask us for one thing. I'm going to show you several different things that's going to help you hopefully understand these confidence intervals. I just marked that wrong. Yeah. 55.2, 59.2. If I write something wrong, please tell me. 55.6. 8.8. D is 5.5. All right, when you're looking at these confidence intervals, and mine don't go by the size of mine or anything, the wider your confidence interval, so the more spread out it is, the higher your percentage of confidence. So if we wanted to do 100%, and we're on this, I might go from, if I go from 0 to 1,000. Well, if I go from 0 to 1,000 with the numbers that we have here, we're 100% confident that our mean's going to fall in that range sometime, right? So that's why we don't do 100%, because you could just pick any random numbers way out on either end and say, hey, I'm 100% confident that every time I ask this question, the mean of people who say yes is going to fall in this range. Well, that's dumb. All right, so we want this, and we're trying to say which one of these, for 17, it's 0.88, 0.90, 0.95, and 0.99. As you're going up with your percentage, as you're getting more confident, what do you think is going to happen to your interval? You're expanding it. You're making it bigger. All right? So we look at this 0.88, we're trying to match them up here. The 0.88 is our smallest confidence percentage. Which one do you think that's going to match up to? C, because it's what? It's the smallest interval. So 17 right here is going to be C, because that's the smallest interval. That's where we have the least amount of confidence. Make any sense? 18, 90%. Well, I'll tell you what, let's jump down to 99, make it easy on ourselves. We jump down to number 20. What should it be?
That's 98.
It's 98.
Yeah, it's 98.
Oh, it's 98.
Should be
The biggest interval still, right? Whether it was 98, 99, it should be the biggest interval. Which one's the biggest? A. So we took care of A, we took care of C. Now for
19
19 is which one?
is B.
B? Is that what you said? Why does Malachi think 19 is B?
Bigger.
It's bigger than that interval, right? So that's B. And what's that leave for this one?
D.
Now the other thing I want to show you on here, we have these two numbers. I'm going to show you here in a few minutes how to find these confidence intervals on your calculator. And on your calculator, it's going to show you this. All right, so you're going to punch in something to your calculator, and it's going to show you the interval that way. Not on the number line, but you need to know that on a number line, it's going to look like that with your limits here and here, and then your mean is going to be in the middle there somewhere, or your X bar. Should actually be X bar, not your mean. Your point of estimate is going to be in the middle there. Looking at this, without looking back at the graph, could I figure out what their X bar was on this certain one? What do I know about X bar and the distance it is from this end and the distance it is from that end? Should be right in the middle. Should be the same on either end, right? So what I can do, the distance from here to there is your margin of error. The distance from here to there is the margin of error. So we could find just by looking at these two numbers, we could find the margin of error and we could find X bar. If we're looking for the margin of error, on this I'm looking for the margin of error. What do I want to do with these two numbers? How could I find the margin of error just using those two numbers?
Add them together.
Add them together,
Divide by 2.
divide by 2. Sort of right. Actually, that's going to tell you the X bar, right? So to find X bar, add and divide by 2. Somebody do that for me real quick. What's 55.2 plus 59.2 divided by 2? Say it again.
57.2.
So what's the point of estimate, the mean in this case? 57.2. Does that make sense? That'd be 57.2?
It's in the middle.
Yeah, it should be right in the middle. Now, let's go back. How would we find the E? How would we find the distance from here to there without using the X bar?
It'd be 2.
Instead of adding, what do? You subtract them and divide by 2. Somebody subtract those two for me and then divide by 2. -2, or actually since we're doing a distance, we're saying how far is it from here to there? Do we want a negative? We just want a positive. So E equals 2. So if they give you, or if you find the two outer limits on those, you add divide by 2, that would tell you the X bar. Subtract divide by 2, that's going to tell you the E, the margin of error. So just different ways you could go from knowing one thing to knowing all the other stuff. What would we do down here on this one, D, since I didn't mark it out? How could we find X bar? What are you going to do with these two numbers? Add them together, divide by 2. What are you going to do to find the margin of error, how far it is from X bar over to here? Subtract them and divide by 2. Problem 21 says construct the indicated confidence interval for the population mean. If convenient, use technology to construct the confidence interval. So now we're actually doing the work here. We're actually making the confidence interval. Watch closely on this one. I'm going to show you both methods on this. Show you how to do it long, just using the chart and math, and then I'll show you how to use your calculator. So we want a confidence interval. What's going to be right in the middle on our graph? 12.3. Next thing we got to find is we got to find E to tell us how far out this way to go, how far out that way to go. And then we'll find these two numbers out here. That's going to create our confidence interval. Right? What was the formula again for E? N's over 30, so we're going to be all right. Now, first thing we got to do is we got to find the confidence or the critical value there. 90's on here, right? Look at 90. What's it say? 1.645. 1.645 times, instead of sigma, you guys told me that since this is larger than 30, we can use what in its place? The sample standard deviation, 1.5 over 50. Right, Sydney? Now what?
Times the top two, divide by 12.
Times, it equals, divide by the square root of 50. What's that give us? 0.348. Is that what you said? Is that right?
348.
Once we have that, now we're trying to find the interval, so we want to find this number and this number. How do we find this number? Using that 12.3 and that number we just found? Subtract. What's 12.3 minus 0.348? 957? 952. So that's that in. How do we find this upper limit? 12.3 plus 0.348. 12.648. That's our interval. That's our confidence interval. And again, what we're saying to explain that confidence interval is we're saying that with 90% confidence, 90% confidence, we can say that mu is between those two numbers that we just found. So if we were looking at the population, we're 90% confident that the mean of the population is always going to fall within that interval. Now let's see, I'll show you how to do it. Have your calculator out and follow along. I'll show you how to do it on the calculator. You got to know, you got to be able to draw this number line though, all right? So the calculator is going to give you something that looks like this as your answer. It's just going to give you an ordered pair, right? It's going to give you the low limit, the high limit. Be able to transfer that to this right here. So on your calculator, what you do, you hit stat. So we're getting away from the second bars one. You hit stat, you go over to test. Go over to test. Anybody see anything on that page that
Interval.
we're looking for a what?
T.
Interval, so guess what we're gonna go down to? Z interval. We don't want the T interval, we're doing Z interval. We will do T intervals here real soon.
I would put it in C.
We hit enter. Now, this is where it's gonna be different, because my calculator is different than yours. So I don't have a clue what your calculators look like. Also, yours does look the same as mine, all right? It's just newer than yours. I thought it was different, because the older ones are different on some of them. So what you do, go down, on the first one it says data or stats. Use data if we're actually punching numbers into the list. This time we're not punching numbers into the list, so we're just going to scroll over to stats. So go over to stats. You don't have to press enter, you just click over to it, then go down to the next line, and stats should stay highlighted, right, or stay darkened or whatever. Oh, you had to press enter? All right, if you have to press enter, then press enter. Then what do we want next?
Well, we don't have Sigma.
We don't have sigma, so what do we put in? We put in the standard deviation of the sample, 1.5. As long as we're bigger than 30, we're allowed to use S in place of sigma.
12.3.
And then our X bar is 12.3. Our N is 50. What's our confidence level that we want? 0.90 or 0.9. Then what are you going to do after that?
Calculate.
Hit calculate. What's it show you?
11.951, comma 12.649. Is that wrong?
That's right.
What did I do wrong?
Um,
11.951 and what?
12.649.
Is that what we got? Pretty real close, right? And I would accept that. What'd you get, Michael? Oh, well, tell me, because I got something screwy too.
It was like 11.2
No,
something.
1.2.
Oh, that's not what it was.
What'd I do wrong here? Oh, I put in 105 instead of 1.5 for the standard deviation. There we go. I just got to make sure that your calculator's doing it, because there's something, I can't remember what it is, but there's something that we had to download to all the calculators, but I think the newer ones have it. So 2 years ago, I had to download, or we had to go in the calculator and turn something on and download something to it so it would do some of the stuff. I can't remember which chapter that was. Did it work out, Michael?
Yeah. I got it.
So that's our confidence interval. Again, notice they write it this way, so you're between this and this. Well, if you have these two numbers, let's say this number's 5, this number's 15. I'm just making up numbers here. That's what the calculator gives you. Could we figure out what E is and what X bar is from just those two numbers?
Yeah.
Yeah. Figure out X bar, we add them together, what's 5 plus 15? 20 divided by 2, so X bar would have to be 10. To figure out E, we subtract them, what's 5 minus 15, or 15 minus 5? 10 divided by 2. So our margin of error there would be 5.
Which is the same as what we did just a little bit earlier, right?
Right. So if you know this, you can find this, and you can find the X bar. You probably already know the X bar anyway, otherwise you couldn't have found the interval. All right? But you can find E going backwards. That sort of make any sense? You guys want to do one more of those real quick? Just want to use the calculator? All right, pick one. I don't care.
23.
23. So 23, somebody tell me what to punch into my calculator, what I hit first. Stat, go over to test,
Z interval.
Z intervals, what we're looking for. We want stats,
Well, your sigma is
2.14.
2.14,
10.5.
10.5, 45.
Yeah.
What's our confidence level that we want?
0.99.
0.99.
Yeah.
Hit calculate, what'd you come up with?
9.683. 11.322.
So if I was gonna draw that on a number line, what number goes right in the middle?
10.5.
10.5. What number goes out here?
9.678.
9.678, something like that. What number goes out here? 11.322. That's our confidence interval. What are we saying about that? That we are, what was our confidence level this time?
99%.
We're 99% confident that no matter what sample or what we get from this, that the mean of that sample or of the population should fall within that range. All right, flip over to the next part, 25 through 28. You should be able to do these without me doing any of them, but we'll do one. Somebody tell me, what's 25 say? 12.0, 14.8. They want you to find X bar, and they want you to find the margin of error. How you gonna find X bar? How you gonna find what's right in the middle? Add them up, divide by 2. Somebody do that for me.
13.4.
13.4. Does it make sense that that's 13.4?
Yeah.
Remember, that's called your point of estimate. That's what you found first. You're saying, all right, this is what I came up with for my sample. I'm not sure that it's ever going to really be that's ever really going to be the mean for the whole population, but it should be within a certain range. What's our margin of error here that we gave ourselves? How can we find that? Subtract the 2 and divide by 2. Now there's another way you could do it. Remember, the margin of error is just this distance from here to there. So you could subtract these 2, divide by 2, that'll give it to you. How else could I find the distance from here to there?
Minus from the mean to
Just minus from the mean to one of those numbers. So could we just do 13.4 minus 12? What's that give you?
the 1.
1.4. What do you get if you add those 2 and divide by 2?
Same thing.
Same thing.
I did it.
So either way,
You can subtract.
Either way, if you know the mean, then we could just take the mean minus one of the 2, or one of the 2 minus the mean, or we could subtract the 2 and divide by 2 to get the margin of error.
That's all
However
we
you
need to
decide.
find.
Do what?
Is that all we need to find?
I think that's all they wanted on those 2, wasn't it? I don't know, I didn't read the direction.
Confidence interval.
Use the given confidence interval to find the margin of error
And set.
and the sample mean. That's all they wanted. All right, set that off to the side for a minute. Get out your notes from last time. We're going to go through this extremely quickly, because there's only really 1 or 2 things that are new. We wrote down a lot of this last time, so you don't have to write it down again. Using sample statistics to estimate a population parameter. What we're doing with all this, I keep saying, the sample mean could fall in there, or the population mean. What we're trying to do with this is we're saying, all right, if I take you guys as a sample and I do all this stuff up here, and then I go out to all the high school seniors and juniors in the whole country, All right, I could use you guys as an estimate for all of those, even though I could never ever actually go out and find out everything about every high school student that's a junior or senior that I probably need to know, right? So I could use you guys as a parameter of the entire population. Now, is that going to be very precise? And that's why we use the confidence interval. We say, all right, well, you guys came up to be 52.8 was your mean. Does that mean that everybody else in the country is going to be at that? No. So what we're going to do is we're saying, all right, we're not sure that everybody else is going to be at 58 or 52.8, but within a certain interval here, we're 95% confident that all the other high school seniors and juniors in the country are going to fall within that interval somewhere. Make your inference. Remember, n's always got to be larger than or equal to 30. Now we're going to learn something else today that sort of makes that sort of obsolete, because just because we have 30 or more doesn't necessarily give us a good sample. There's a way that we can find n and say, okay, now we're a little more confident with our sample. Because if I just pick 30 people, if I'm doing all the high school juniors and seniors, is sampling 30 going to be enough in the whole United States? No, there's too many of them. That's too small a sample out of too big a group. Normally, if it's normally distributed and you know the sigma, normally we don't know the sigma, so if we don't know the sigma, what do we put in its place? Standard deviation of the sample. Remember what S means. Point of estimate. Your point of estimate is your X bar. We went over this last time. Interval of estimate. We got our point of estimate right in the middle. Some interval out here, that's what we were just doing. We're skipping over this real quick because we went over this last time. Your level of confidence. Level of confidence is C. Don't get C confused. That's level of confidence. What's ZC stand for? Critical value. Right? So C is your level of confidence. That's the percentage. C is that. Z is the actual critical value on the normal curve. We have that chart. The one on your paper actually has 80% on it also. Make sure you use that. Most everything that we do will be 80, 90, 95, or 99. Instead of finding the Z-score, the critical values, by doing all that math, use that chart. Remember your critical values, what you're looking at. If it's 90%, then we want 90% of it to be in here. So our critical values are showing 5% on this side, 5% on that side. Just said that, didn't realize that slide was on there. Level of confidence C, we just talked about that. So on, same idea. Remember, you take, if this is 90% in here, we take 100 minus 90, divide by 2, that gives us this part and that part. We just did all that, that's why I'm going so quickly over it. Same thing there, 5% on each side. Sampling error. We didn't talk a whole lot about sampling error because we don't use sampling error near as much. Sampling error is just X bar minus mu. Why might we not use sampling error very often? What can't we find usually? We usually can't find mu. We usually don't have any idea what the actual population mean is. All right? Otherwise, if we knew the population mean, would we be doing all this stuff? Probably not. No reason to give an interval if we know the population mean is exactly right here. So sampling error, we don't use it very often. Margin of error. What's the letter it stands for margin of error? E. Margin of error is that big E. That's the formula for margin of error. Again, we're probably going to use that formula instead of this because all this right here is. That's our standard error from last chapter, and to find the standard error, we got to do it this way anyway. Normally, what are we going to put in place of sigma right there? The sample standard deviation, good? You gotta yell at me every now and then, all right? Because I forgot that you weren't here last time, so I've been rushing through, but that's really the first thing that probably. So E equals that. That's called different names. You probably won't hear me call it a different name because I can't remember all those different names. To find our margin, to find our interval, X bar minus E on the low side, mu's in the middle, X bar plus E on the other side. So if we wanted to write it something like this, mu has to be between something and something. Like I said, mu, I just did that example a couple minutes ago, and we said mu had to be between 5 and 15. That's all you're doing there. Just another way to write it. But to find the low limit, X bar minus the margin of error. To find the high limit, X bar plus the margin of error. We just did all this. If you want to write any of it down, that's fine. That's up to you. But was it really that difficult once we did a couple of them? Not really. You find your sample statistic. This time we were finding X bar. Remember, you find X bar by adding up all the items in the set, divided by how many of them there are. Make sure that we're larger than 30. On this part, when we're doing this, we didn't do it this time, but does everybody remember those charts that we made back at the start of the year that had like X bar minus X and then X bar minus X squared and all that stuff? We probably don't want to go back to those charts, do we? I know Molly liked doing them, but it's because Molly's sort of strange sometimes, right, Molly? You're not strange. Nobody liked doing those charts, big long things, and then that gave us, remember way down here at the bottom, it gave us like the standard deviation, or I'm sorry, it didn't give us standard deviation. Gave us the variance, and then we had to take the square root of that to find the standard deviation. Probably don't want to go back to that. Don't forget about them, though. You like them? It's because you're a different kind of person now. You're just that kind of great person. Find the critical values. We're going to find the critical values. You could use the table, or you could use the calculator. Remember, if it's not the 80, 90, 95, or 99, then you use what? Inverse, norm, and put in the area. And that'll tell you the critical value. Remember, you want your critical value to be positive. It's normally going to give it to you as a negative. Find the margin of error. We just got done doing that. E equals, E doesn't equal MC squared, so don't think that. This is the wrong E. All right? E equals CC times sigma over square root of n, where sigma, again, it's probably going to be S. Then take your X bar, subtract off your margin of error, take your X bar, add the margin of error, and that gives you the two numbers for your interval ends. Mu is a fixed number. There's some mu out there for every population that's right in the middle. All right? Can we ever find it? Probably not for most populations. But it is a fixed number. And we're just looking at that confidence interval. trying to say, hey, we know that mu's going to fall within this range. So again, we're not saying there's a 90% probability that the mean falls in there. We're saying we're 90% confident that the mean of the population falls in there. Saying that there's a 90% probability that the mean falls in this range isn't good, because that means there's a 10% probability that it's going to fall where? Outside of it. And it shouldn't, right? It should be most definitely almost 100% of the time in this range somewhere. And that's what this is showing. So if I do all these different samples, each one of these bars is a sample. My population mean is this red line going up through there. On every one of these samples, except for that crazy one right there, did the mean fall in those ranges?
Yeah.
Yeah, and that's what we're saying. Hey, there might be that one sample that we get that's an oddball, but almost all the time, the mean's going to fall somewhere in there. If you wanted to write this down, this is what you do on the calculator. I know Miss Clark was writing it down as we were doing it. If you wanted to write it down now, might be helpful. This is going to give you the confidence interval. Remember, the calculator is going to write the confidence interval like that. You've got to be able to translate that over to other stuff. Over to a number line. Couple of things. What are you going to probably put in for sigma there? Probably S. Sample standard deviation, because we usually don't know sigma. We usually don't know the population. Remember your sea level, that's your percentage.
Senior night way.
Senior night.
I know today was senior night, so you can come over here and slob.
What time do you start?
9.
It starts at 9.
Since the freshmen have a game.
What starts at 9?
All three of them.
Don't let him lie to you, Katie.
She knew. She knew if it was 9. She told me.
So it starts at 7?
Does everybody have that before I change it?
7 or 9 to be honest. Are you coming too?
I don't know. Are you playing?
Yeah. My second start.
What was the last time you said that?
Next time.
So only the games I've been to, you started. That's the only game I've been to.
Which
You
game
didn't
is?
miss it all about it?
You really went to?
That's
Why? Are you close there?
No. I just hadn't seen you guys play yet this year, and I didn't.
So you travel like the farthest?
I didn't have any other chances. I mean, I try to go see you when you play other places, but I just haven't had the chance. You guys, every time you guys play, then I got something else that I think a couple of times went and watched UD play, and you guys are playing. I already paid for those tickets. I'm not dumping those to come watch Malachi, so sorry.
Alright.
What's higher to be?
I've been to see Been to watch the girls play like 3
They
times.
let him play like once a year for
Yeah.
JV.
Now he plays 2.
Who's that?
Hunter Miller.
And he's playing tonight.
Blind kid, can't see.
He's not blind, he has one eye.
He can't see.
Wait, what? Seriously?
Yes.
He's like the. I didn't know that.
I know the name, I just can't picture the face.
If you write.
They
What
can't
time's
distract
he
you.
play?
He plays
Oh,
JV.
okay,
Yeah, no,
yeah.
what time's that?
All right.
That's it.
All right, this we did not write down last time. Let's do this real quick so we can get through it. And I'll tell you guys a funny story if you want to hear a funny story
Yes.
about me going to a basketball game.
Wait, ours?
No, it was one of the girls' games.
Let's hear it right now. I'll write it down.
Nah, I'm gonna wait till I'm done because I'm turning off the thing because I don't want it. I don't want everybody in the world to know how dumb I am.
He showed up to the wrong girl's game.
He did, didn't
Thought the boys were playing.
All right, so given a C confidence level and a margin of error, so if they're telling you your confidence level that you want, your margin of error, we can find the minimum sample size needed to estimate the population mean. So now we're actually saying we want to know, and this is what, when you hear all these things on the news about the president's approval rating and stuff like that, these people who find those things are supposed to do something like this. They're supposed to find the minimum amount of people that they actually need to interview to come up with a good sample. All right? Now, do you think they always do that? Probably not. So you got to listen closely because I heard one on the news yesterday, and it said something, 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 plus or minus 5. All right? That's not bad, plus or minus 5. But then I remember back when the election was going on, that they were saying, you know, chance of Hillary winning this state is 12, some, you know, whatever, and then sort of under the barrel, plus or minus 15. You know, it was sort of, well, if it's plus or minus 15, that's a pretty wide spread. You know, so they're saying the percent is 62% plus or minus 20. Well, that means it's going from 82% down to 42%. Well, I hope her percentage rating's in there somewhere, because otherwise, either she's just completely, nobody likes her, or every person likes her. So to make that range sort of crappy, and what they did there is they didn't have a big enough sample size. So to find the sample size, we use the critical value times sigma. Again, it's probably going to be an S there, divided by the margin of error, and all that squared. And that'll tell us how many people we need. If you come up with something like this, what are you going to do with that? Can N be 100.8?
No.
Doesn't make sense for N to be 100.8. We're not going to find the 0.8 of a person. So what are we probably going to change that to? We need at least 101. Even if it's this. What are we still going to round that to? Still 101. You still round it up. Go up to that next one. All right, so go up to that next one. So round up. We're going to skip over this. Same idea as all the stuff that we just did. You have to find the critical value. Use your S here. E is 1. And then we can just plug in there. So this says 96.04. So how many people would we need to interview if we're doing this to get a good sample? At least 97. At least 97. That's all we're saying with that. We're just finding that sample size. Skipping a bunch of this stuff. All right. Add this to that 1 through 28. This is your assignment. It's not near as much as it looks like. Maybe if Malachi doesn't throw too big a fit.